My name is Matt Kunkel. I'm the Director of Operations at Door Engineering, where we service a wide array of customers on our industrial and commercial side, as well as our aviation side through bottom rolling, vertical, and tip-up doors. At Door Engineering, we provide creative customer solutions to very challenging customer applications throughout our field. So that entails, let's say, firehouse stations where we have a biparting horizontal folding door. And that's our most common application where people can kind of see us in the public. We've provided the doors to restaurants, auto dealers, and several other entities that use our product. We have a wide range of applications, anywhere from bulletproof applications, lead lined, and for hurricane and tornado resistance. When we invested in robotic welding, we were primarily focused on what we were going to do to set ourselves up for the future in terms of growth and in terms of productivity improvements. With some of the challenges we faced in southern Minnesota around staffing, we knew that we needed a solution that was going to be able to take us to run 24/7 on a wide array of challenging products. We knew we needed variability in the equipment that we could easily program and adjust to our diverse customer needs.
At Door Engineering, we manufacture large steel structural door systems. With these door systems, they consist of parts. They can be structural tubular frames. They can be door panels, track systems, but large steel structural systems. We provide pre-engineered and custom door solutions to the market. We produce parts that are mostly project-based, and so they can vary significantly between geometry, size, and application. Welding is a key part of joining metal structural members to form the door systems. It is important that the shop floor is flexible, as we could have many different projects running on the shop floor at any given time. Quality is also a key part in the structural fabrication of these door systems. With our production mix, we have loaded over 200 different models onto this robotic weld system successfully and welded them. It's important that we check the parts, that they are accurate and correct to the 3D CAD model of the design. This software does that. Multiple parts can be loaded on the system at the same time, really providing a good mix and repeatability and flexibility on the shop floor that is needed. When these variety of parts are loaded in the robotic weld cell, they can just be placed with no fixturing for ease of use and quick changeovers between product type and style. The system also adapts to the real geometry of the parts, building in the tolerances of the design. We have 4 different weld zones, and so we can be welding in one zone while people are preparing and unloading the completed parts in another, keeping the utilization of the robot up on the production line. The robot is the first piece of equipment that strikes an arc in the morning and the last one to strike an arc at the end of shift. Our part mix is 50-50 between pre-engineered standard parts and highly custom parts. The system is highly adaptable, where we can be running small standard parts and large custom parts at the same time simultaneously. So programming happens offline before production starts making the product. What we do, we have manufacturing engineers that do the program, and they can simulate the part welding before it actually hits the cell, troubleshooting and overcoming any challenges that might arise during the welding of these parts. Once that's done and the parts are ready to be produced, the operator will start the program, scan the parts, and ensure that the parts match the CAD data. This is important, especially with the high mix environment that we're in. With the 4 robotic weld zones that we have, we can combine 2 weld zones to make an extra long 60-foot by 7-foot weld area to process parts. If parts fall outside this envelope, we can weld it partially in a phase 1 and then switch it over to weld the remainder using the software easily and repeatedly.
So we import parts into our system, and then we can look at them on our computer screen, and our scanner will scan it in real time and identify where the parts are. The system was very easy to use. We did not have to know any programming languages. It was kind of like a computer game. You just click, apply your settings, and move on with your process. No, you do not need programming skills to use ABAGY. It is very easy. We've trained people with no computer knowledge, really, all the way up to be our operators. I describe the software interface as being easy to use. We're able to utilize templates, so we're able to copy and paste different settings, which really incredibly reduces our lead time and getting programs ready for a shop floor to use. So switching between different parts, you just select a new job. We have all of ours labeled by job number, so it's very easy to see what we're working on and see what parts we have on our floor. When something goes wrong, the error codes usually pop up, and they're very informational, so they're easy to follow. And if we still can't figure it out from there, we use Mattermost, which is a chat with our support team.
Multiple parts can be preloaded on the system to run in batch, form, or continuous production part by part. Typically at the end of a shift, we can load multiple parts at a given time, press go, and the robot will weld lights out with nobody monitoring the robotic weld cell. Large structural components can be prepared in the cell while the robot's working in another zone. When it's time to weld the parts, the robot system can be switched to that active zone and combined into a larger zone if required. The system will scan this large part, ensuring that it's correct to the design data. And once that's done, it will execute the welding. We have parts that have had hundreds of weld seams, all done while the welder's actually preparing other parts. In day-to-day production, we have 2 to 3 shifts available to run in the robotic weld cell. This system ensures that we fully utilize the robot during production. While it's zoning in zone 1, parts can be prepared and unloaded in zone 2, 3, and 4. These zones can be combined into larger zones and can also have batch processing capability of multiple parts. Production personnel work with the robot, ensuring that it has parts to process, and once that's done, it can move to another zone while the operator checks, verifies, and moves the parts onto post-processing. Operation of the robot is repeatable and consistent, and so once we have defined welding parameters, we know with confidence that these parts can be processed accurately and according to design standards. Our rework has significantly reduced. With the robot, we have consistent weld size, placement, and heat input into our parts. This has reduced heat distortion that we saw with manually welded parts, and also weld seams that are out of specification, typically oversized, has significantly reduced with the robot welding to the approved and qualified welding parameters. We have been provided great support by the ABAGY team remotely. We have a communication platform that we can deal with an engineer remotely 24/7. We can also control the robotic weld cell remotely, and so can the support team abroad. ABAGY response time has been fast, and we've had minimal downtime in the robotic weld cell. With just routine maintenance checks of the robot and within the cell and the equipment, we have had a very high uptime in the robotic weld cell. Flexibility is so important to us in our production environments. We can have parts that can be 4 foot long one day and then up to 60 foot long in another. And so flexibility and repeatability is important. Once the parts are processed in the robotic weld cell and they move on to post-processing, we know with confidence that these parts are correct to design and within welding qualification and certification. The robotic weld cell requires low supervision. It can be run with the operators and manufacturing engineers creating the programs and knowing that when parts leave the robotic weld cell, they are correct and to standard.
I'm Kawasaki. I'm the robotic operator here at Door Engineering. So what I usually do, I load up to the work zone, and it doesn't need to be perfect. The robot kind of understands where the parts are positioned. I scan it, it just finds it, I match it, and we're good. The work cell is very safe. As soon as you cross the safety curtains, it will completely stop the robot. There's e-brakes everywhere, but it knows when someone's inside the zone, the work zone. So it will stop it whatever it's doing, protects you from anything.
ABAGY has been a great partner in providing the solution to the manufacturing floor. With this system and relationship with ABAGY, we have created a great solution for welding in a high mix environment. They have provided expertise in implementing this robotic weld cell from day one. And after 2 years, still support us on day-to-day operations.
Since implementation of the equipment, really we have seen a significant amount of growth around our partners in the aviation industry, where we see a much more variable product. With this system in place, we've been able to increase the uptime through partnering with the manufacturing engineers on site, as well as some of our skilled labor to creatively come up with solutions to run that product in a 24/7 environment, as opposed to hand fabrication, hand welding, and much more labor-intensive means. We were able to turn those products, put them on the automated welding system, and then use that equipment in a better capacity for our people across the shop. This system enables us to really grow our platform and continue to grow our business at an exponential rate. If you look at our business over the last 3 years, we've grown significantly, approximately 60%, and we continue to look at that kind of growth in the future as we recognize and administer deals with some of our aviation partners in the future. Without this automation, we would be handcuffed to some of the local talent that we have in some of our specialized welding applications. And with that, what we can use this equipment for is quickly transition and quickly train people to utilize the equipment, where we're going to be able to provide a higher quality product to our customers and build on efficiencies that will lead to some increased business and increased growth in the future. I would say if you have a significant variation in product and you have a need for talented, skilled people that is in a market that's difficult to attain, I would strongly leverage purchasing this automation in order to close the gap and ensure that you're meeting your customers' needs, not just for today, but in the future. This system has provided us a significant amount of opportunity, not just to improve our quality standards here on site, but also improve what we provide to the customer in terms of that out-of-the-box experience.